Resources are incredibly important in the way that we live our lives. And the question is, where will those resources come from in the future? So right now, today, there are nearly 8 billion people on planet Earth. And every one of those people wants a long list of commodities, things like televisions and computers, and perhaps even tiny robots. With so many of us, that's an awful lot of stuff. To give you an idea of the magnitude of the problem, the yearly demand for copper is 28 million tons. That's enough copper to fill up the Empire State Building 3 times over. Unless we find 28 million tons of new copper every year, we can't make all those things that we want. Industry cannot function. Now the problem is we've been digging up copper for nearly 4,000 years. You simply don't find large lumps of native copper lying around on the Earth's surface anymore. All the easy to find copper has gone. In fact, today, looking for copper is like looking for the needle in the haystack. A good copper ore might contain 0.6% copper. Now, the reason that that is worth digging up is simply about price and cost. If the cost of digging all that rock out of the ground is less than the price someone is willing to pay for the copper, then there's a profit to be made. And like any other business, mining is all about profit. But resources can have hidden costs that aren't considered when deciding whether you can dig them out of the ground and sell them to someone else at a profit. Fossil fuels are the best example. Now, fossil fuels have been great. They have driven our civilization since the Industrial Revolution because they give us cheap energy. No one realized that burning fossil fuels release so much carbon dioxide that it would trap heat from the sun and cause global climate change. Now, since the Industrial Revolution, we have released so much carbon dioxide that we have increased global temperature by 1 degree Celsius and caused extreme weather events and rendered some parts of the planet almost uninhabitable. Now, it's difficult to put an exact cost on global climate change, but it's probably in trillions of dollars. And if we don't do something about climate change, if it caused ecosystems to collapse and threatened food production, it could cause the end of our civilization. So burning fossil fuels could cost us everything, all the money in the world. And that's an unacceptably high cost. And of course the solution is renewable energy. To generate energy using wind power, or hydroelectric and tidal power, or solar energy, and then to use that energy in our electrical devices. So we all need to give up our petroleum-driven cars and turn them into electric vehicles. But to do this, we need batteries. We need to store that energy at the point of use. So we need rechargeable, high-capacity batteries. And that demands new resources. So both nickel and cobalt are essential in rechargeable batteries. It's these elements that make them really high capacity and allow them to drive electric vehicles. And so we need to mine and extract nickel and cobalt to save the planet. And that's where the problem is. There really isn't much nickel and cobalt on Earth. The global demand for nickel is currently 2 million tons per year. And we think that that will increase by 2040 to 4 million tons per year as more and more of us have electric vehicles. The global reserve of nickel, and this is the nickel that we know exists, is 90 million tons. And the estimate for the total amount of extractable nickel, 300 million tons. So if you do your maths, all the nickel runs out in 75 years. One human lifetime, and then there's no more nickel. Now, of course, recycling will help. If we recycle our batteries and recover most of that nickel, it extends the lifetime of nickel quite a lot. But still, recycling cannot be 100% efficient. We still will run out of nickel eventually. And that's a metal that we need to save our planet. We need it for renewable energy. The reason there's so little mineable nickel on Earth is because nickel loves being with iron in metal. So where the metal goes, the nickel goes. If we slice open our planet, we can see where most of the metal is. It's in the Earth's core. Now the core formed very early, with the metal being really dense, settling out to the centre of the Earth. And it took the nickel with it. Now we are more likely to stand on the surface of a planet around another star than we are to ever reach the Earth's core. The conditions are just so extreme. So all that nickel is out of our greedy little hands forever. So where does our nickel come from? Well, most of it comes from old volcanoes. In magmas, when there is little oxygen, which happens quite rarely, when there's little oxygen, the iron and the nickel can combine with sulfur to make an immiscible liquid. An immiscible is like oil and water. The magma and the sulfide liquid do not mix. Now these blobs of sulfide liquid are dense, and so they settle to the base of the magma chamber and collect. And when elements are concentrated, it makes them a valuable ore. Nickel can also be found in mud. When lava flows are altered by water for tens to hundreds of millions of years, they develop deep soil layers. And nickel can be leached out of those igneous rocks and concentrated in the deep layers of the soil. And these are mainly found in the tropics and are called nickel laterites. Large amounts of nickel may also be present in nodules on the ocean floor. Now no one quite knows exactly how much nickel is present in the oceans. But what we do know is that it will be difficult to extract without causing significant damage to the delicate ecosystems that exist in this extreme environment. And usually the more extreme the environment, the more sensitive the ecosystem is to change. We also don't know exactly how important the deep seas are to the overall health of the oceans. And that's crucial, because it's the oceans that absorb most of the carbon dioxide that we produce. If it were not for the oceans, climate change would be significantly worse. So although there may be a lot of nickel at the bottom of the oceans, extracting it could be very dangerous indeed. There is another source of nickel on the surface of the Earth, and that's found in meteorites, in rocks from outer space that have fallen on the surface of our planet. Iron meteorites contain between 6 and 20% nickel, making them really good nickel ores. But unfortunately, there's not many of them. Only around 100 tons of meteorites falls every year, and most of those are not iron meteorites. And that's far too little for us to use in renewable energy. But perhaps we could use the sources of those meteorites, because meteorites are fragments of asteroids, and they tell us that asteroids contain abundant nickel. So perhaps we could mine asteroids to satisfy the world's demand for nickel. The reason that some asteroids contain lots of nickel is because they melted early in their history. And just like on Earth, the metal, being densest, settled to make a core. So some asteroids had cores, but unlike on our planet, collisions between asteroids exposed those cores at the surface, where we can access them. The largest known M-type asteroid that's probably made out of metal is 16 Psyche, and it's 113 kilometers in diameter. Now that is a giant piece of metal. So if there is so much nickel in space, why are we not mining it already? And of course the reason is it's really expensive. So it might just be a short hop to go from the Earth's surface into outer space, only 150 kilometers or so. And yet the Earth's gravity makes that really difficult. It costs $3,000 per kilogram to deliver material into space. So if you need to send the components of your spacecraft, the mining equipment, and all the fuel that you need to travel to the asteroid and back, that's enormously expensive. And then you need to drop the nickel back down to the Earth's surface, a really significant technical challenge. And so right now, it's not profitable to mine nickel on asteroids, and mining companies need to make a profit. But remember, we said that the costs of a resource are not just the expense of extracting it from the ground. Any of our activities on Earth, whether they be mining or industry, impacts the environment. And every habitat we lose, every species that becomes extinct, has a huge cost to the human race and to our planet. Now, of course, that doesn't make mining any more economic in space, but it does give governments a reason to invest in space mining. Space agencies are already developing technology for mining in space. They call it in situ resource utilization, and it's to generate resources that can be used by space missions or future crewed bases, for example on the moon. It's these technologies that will demonstrate that space mining is possible. And perhaps more importantly, space missions run by governments and space agencies develop infrastructure, such as space stations, and those are likely to be crucial when it comes to industry working in space. It's likely to be infrastructure that makes space mining a reality. If mining companies can build spacecraft in space and launch them from orbit rather than from the Earth's surface, if they can use fuel that's also obtained in space, then costs will become dramatically lower. If companies are supported by a business ecosystem, with some companies providing fuel, others construction, and others transport, then there may be huge profits to be made in this new space economy. Despite all the difficulties, mining in outer space is probably inevitable. We have a choice. Our key metals are running out and will run out. We can either choose to mine asteroids, or our technological civilization will end and we go back to using stone tools. The rewards of mining asteroids are potentially huge. They not only secure our future, but also the future of our planet by protecting the environment from at least some of our activities. And that future may be very long. If you look at asteroid 16 Psyche, it could provide the world's current nickel demand for 900 million years.